Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve questions from the midsem paper of fluid mechanics. So in yesterday's lecture, we already solved this problem and this problem. So in today, we are going to solve this problem. You can read the problem over here. The potential function for a 2D flow field is given as phi is equals to x square minus y square plus 2x minus 2y. Find out if the flow exists. Okay, first let us discuss about what is a potential function. First, for a potential function, our first assumption is flow is irrotational, right? There is another type of function also, stream function. For that, we assume that flow is incompressible. So potential function is only defined when the flow is irrotational. Stream function is only defined when the flow is incompressible. So if for a flow, both potential and stream functions exist, then flow is irrotational and incompressible. Okay, and we already know that for a potential function, dou phi by dou x will be is equals to minus u. U is velocity in x direction. Dou phi by dou y will be is equals to minus v. V is velocity in y direction. For a stream function, dou psi by dou x will be is equals to v, and dou psi by dou y will be is equals to minus u. So simple, if you take x-axis and if you take y-axis, for psi function, you need to go 90 degrees from x-axis, then we will get in anti-clockwise, then we will get y, right? So dou psi by dou x, if you go 90 degrees from x-axis, we will get velocity of y direction. So dou psi by dou x will be v. So if you go 90 degrees anti-clockwise from y-axis, then you will get minus x, means minus u. So dou psi by dou y will be is equals to minus u. You can think like that. So similarly for potential function, this is y, this is x. So you should go 180 degrees. So if you go 180 degrees anti-clockwise from x direction, you will get minus x, means minus u. So dou phi by dou x will be is equals to minus u. And if you go 180 degrees from y axis, then you will get minus y axis. So dou psi by dou y will be is equals to minus v. You can take reverse sign conventions also. This is one of the sign conventions possible. So first we need to find whether flow exists or not. For that, we already know that for a flow to exist, del dot v bar should be is equals to 0. This is continuity equation for incompressible fluid. Okay, so we already know that dou psi by dou x, this will give us dou u by dou x plus dou v by dou y will be is equals to 0, right? So we already know dou psi by dou x is equals to minus u, dou phi by dou y is equals to minus v. So from this we get dou square phi by dou x square plus dou square phi by dou y square will be is equals to 0, right? Means the Laplace of potential function will be is equals to 0. So potential function, we already know potential function for that flow, x square minus y square plus 2x minus 2y. So then dou square phi by dou x square, it will be 1, right? And dou square phi by dou y square, that will be minus 1. So 1 plus minus 1, that will be 0. So flow will exist. This is first part of the question. Next question, find the discharge through a cross section PQ where the coordinates of points are given P 2, 4 and Q 4, 9. It is 1.5 marks. So for second part, so suppose this is point P and this is point Q, and if so discharge through this area line joining P and Q will be given by flow per unit length. Suppose this is yx coordinate system, then z is into the plane of the paper, then unit length in z perpendicular z direction, okay, will be given by psi 2 minus psi 1. And suppose this point is 1, this point is 2. Okay. So what is psi? Psi is stream function. So stream function value at 2 minus stream function value at 1. So we need to find stream function for this. So we already know dou phi by dou x is equals to minus u. So and we already know u is equals to, you see over here, u for u we have dou psi by dou y, right? So you can write over here dou psi by dou y. So dou psi by dou y, dou x will be is equals to dou psi by dou y minus okay, sorry, plus. So from this we get dou psi will be is equals to dou phi by dou x into dou y integral. So from this we get psi will be is equals to, what is dou psi by dou x? Dou psi by dou x, dou psi by dou x will be is equals to 2x, right? Sorry, 2x plus 2 means 2 of x plus 1. So from this we get integral 2 of x plus 1 into dou y. So that will give us psi of x comma y is equals to 2y of x plus 1 plus f of y, sorry, f of x. Do you agree? Plus some constant k. So now this is 1, and we also know that dou psi by dou y will be is equals to minus b, that will be is equals to minus dou psi by dou x. So what is the value of dou psi by dou y? Dou psi by dou y will be is equals to minus 2y minus 2. So that is minus 2 of y plus 1, right? So from this we get dou psi by dou x will be is equals to dou phi by dou y minus, so from this dou psi integration will be is equals to integral minus dou phi by dou y into dou x, right? So from this we get psi of x comma y will be is equals to minus, this will be 2 of y plus 1 minus, right, into dou x. So that is integral. So we get psi of x comma y will be is equals to 2x of y plus 1 plus, what is the constant? Constant will be some function f of y plus some z, some t, let us assume. So from this is equation 1 and this is equation 2. So from this psi of x comma y will be, so if you express, if you write like this, 2xy plus 2y, right? So this is plus f of x plus k, and this will give us 2xy plus 2y plus f of t, sorry, this will be 2x, right? So from these two equations we can say that the psi function will be 2xy plus 2y plus 2x plus some constant k. So here f of x will be 2x and f of y will be 2y, and k and t are equal, then we will get this psi of x comma y, both should be equal, right? So we need to find out discharge to the cross section PQ, right? So it will be psi of x comma y cube will give us 2 into, what's the value of coordinates of q? 4 comma 9. Let us put that 4 into 9 plus 2 into 9 plus 2 into 4 plus k. So that will give us 8 into 9, 7. This is 8 into 9, 72. This is 18 and this is 8. So this will give us 98 plus k, right? So and psi of x comma y of p will be 2 into x into y. X will be 2, y will be 4. So into 2 into 4 plus 2 into 4 plus 2 into 2 plus k. That will give us 2 into 2, 4 into 4, 16, 8. So this is 28 plus k. We already said that flow rate per unit length in z direction will be is equal to psi 2 minus psi 1. So what is psi 2? Psi at q, that is 98 plus k, minus what is psi 1? That is 28 plus k. So we will get psi 2 minus psi 1 will be is equals to 70 units. Okay. So that is the discharge. The discharge value is 70. Flow exists. So answer is 1 for this, and this value is 70. Okay. With this, we complete today's lecture. Next lecture, we solve remaining problems of this paper. Thank you.